All right, today we're going to continue graphing quadratic equations. We're now looking at something called intercept form. So at this point in the chapter, we have looked at vertex form and we took a quiz and looked at standard form. And now we're going to do the third and final form for this chapter, which is called intercept form. Intercept form is written as y equals a times the quantity x minus p times the quantity x minus q. Okay, A is still what tells us, so this value out here, A, still tells us if it's a reflection, that's if A is negative, if it's a stretch, if A is greater than 1, or if it's a shrink, if A falls between 0 and 1. Now, if you look at the rest of this, though, this is what we did earlier when we looked at factoring. So what we're going to do is in order to put it in intercept form, we have to have it in factored form. So we're going to take our equation and we are going to factor it. Now, the big thing here, what helps us with intercept form, is we are going to be looking for the x-intercepts of the graph. The way we do that is we take our factored form, our factors, and we set them equal to 0, and then we solve. Those answers, P and Q, become the x-intercept. So the ordered pairs would be P comma 0 or Q comma 0, because remember, to find an x-intercept, you plug 0 in for y and you solve. Now, once you have P and Q, so at this point, here's what we know. We would have 2 points. So we would have a point, let's just say here and here. When I go to look for the axis of symmetry, well, if these 2 points are on the x-axis, that means they have to map onto each other. If I fold it along the axis of symmetry, those 2 points would have to land on each other. So what that tells me is right down the middle of those x-intercepts, that is going to be my axis of symmetry. The way we find that is we can take the two x-intercepts, add them together, and simply divide by 2. And that will give us our axis of symmetry. Once we have that, we simply plug that value back into the equation for the x's, and we simply solve for the y, and this will give us our vertex form, which is x comma y. That will give us our vertex of that quadratic. Then what we can do is we can take and use our movement. Remember, we have those movements where we go right 1, up 1, right 2, up 4. Those still work. Left 1, up 1, left 2, up 4. And those work for all 3 methods. And also, if we have a stretch or a shrink, we can just alter the up values just like what we did back at the beginning. Okay? So let's take a look at these problems. So this first part is I just want you to, given a graph, can you spot where things are? So we're going to start with this first one here, and I'm going to ask you for the vertex. Well, remember the vertex is, in this one, is at the bottom of the U shape, the parabola. So the vertex here would be at 3, -4. Okay? Once again, it is a minimum in this case. The axis of symmetry, remember, that is the line that goes through the vertex. So it would be the equation x equals 3. The y-intercepts, to find the y-intercept, we simply come over here to the graph and we look, where does the graph cross the y-axis? And the y-intercept on this problem would be a 5. And then the last one, the x-intercepts, we're going to ask, where does it cross the x-axis? And in this case, it would be at 1 and 5. Okay, let's try the second example here. So we're going to start off with the vertex. So the vertex is the middle of that U. So this time it is at -1, 4. The axis of symmetry, remember, it goes right through that vertex. So the axis of symmetry would be x equals -1. The y-intercept is where it crosses the y-axis, so the y-intercept is 3. And then the x-intercepts are at 1 and -3. And that's how we just pick off those vocabulary words. Remember, vertex is the middle of the U. Axis of symmetry goes through that vertex, and it has the same x value as the vertex. The y-intercept is where it crosses the y-axis, and the x-intercepts are where it crosses the x-axis. If you ever have one where it doesn't come out to be like 1 or 2, you can approximate that. You can do an estimate of where you think that falls. Okay, so you could estimate like a half or something like that if your x-intercepts don't come out to be nice, neat, whole numbers. All right, so now let's do some graphing in intercept form. So the first thing I notice is I am in intercept form because I already have it in factored form here. So the first thing I want to do is I want to find my x-intercepts. So what I'm going to do is I'm going to take each of my factors and I set them equal to 0. So now I go to solve this. So I'm going to add 3 to both sides. So x equals 3. Over here, I'm going to minus 1 from both sides. So x equals -1. So my x-intercepts are -1 and a positive 3. So now what that gives me is I'm going to come over here. I've got an x-intercept at -1. I've got an x-intercept at a positive 3. All right, my next part then is I want to find the axis of symmetry. So the way that we do that is we literally just go x equals, take your x-intercepts, -1 plus 3, divide by 2, which will put us, our x-axis of symmetry will be at a positive 1. Now, what that reminds me is, tells me that that is where my vertex is going to be. So my vertex value, the x value is still a 1. Now, to find the answer to that, we are simply going to go y equals 1 minus 3 times 1 plus 1. Well, 1 minus 3 is -2. 1 plus 1 is 2, so -2 times 2 gives me -4. So I'm going to come over here, 1, 2, 3, 4. There is my vertex. My y-intercept, remember to do that, we plug 0 in for the x. So if I plug 0 in, that's gone and that's gone. So now I just have -3 times 1. So my y-intercept would be at -3. Reflect it over, and there is our graph. Okay? So that was a problem where it was already given to us in factored form. Okay, let's try another one. So the first thing we're going to do is we need to factor this. So we start off and we say, okay, is there a GCF that goes into all 3? And that answer would be no, there's not. So now I go to try to factor the polynomial, the trinomial. So the factors of x squared, we have x and x. Now, I do need you to fix a typo here. This is going to be a +8. Sorry about that. That's just a typo on my part. So we're going to take the positive here, tells me that it's the same sign. Then the -6 is telling me that it's going to be both negative. So then we look at factors of 8. So we have 1 and 8, or we have 2 and 4. So here, in order to add up to 6, we're going to have a 2 and a 4. So that is my factored polynomial. Now I go to find the x-intercept. So I'm going to go x minus 2 equals 0, or I go x minus 4 equals 0. I go to solve those, and I get x equals 4 or x equals 2. So I have 2 x-intercepts at 2 and 4. So I come over here, at 2 I put a dot, At 4, I put a dot. There's my x-intercepts. Now, we could take this and we could just simply say, okay, x equals 2 plus 4 divided by 2, which is 3. But we can also look at the graph, and we should be able to recognize that halfway in between those two numbers is going to be 3. There's my axis of symmetry. Now we're going to take the 3, plug it back in. Now, you can do this one of two ways. You could plug it into your factored form, or you can plug it into your original equation, whichever way makes it easier for you. So what I'm going to do is I'm going to plug it into my factored form. So I would go 3 minus 2 times 3 minus 4. So when I do that, 3 minus 2 is 1, 3 minus 4 is negative 1. So when I multiply that, I get a negative 1. If I plug it into the original, it would be 3 squared is 9. 6 times 3 is 18. So 9 minus 18 is negative 9. Plus 8 is a negative 1. You get the same thing either way. Then the last thing, if I plug 0 in, I do find that when I find the y-intercept, plugging 0 into the x's, I always feel is a little easier when you plug it into the original standard form. Because remember, then that comes out to just be the c value. So if I came over here and graph that, it would be here. So I could take that and reflect it over. If I want to put another point, I could go right 1 up 1. Now I could go right 2 up 4. Reflect it over. And there's my graph. And there's your quadratic. Okay, let's go to this next one here. So the first thing we're going to do is we are going to factor it. So I start in and I go y equals. Now, this time, hopefully you notice it has a GCF. And it is x. So I can take the x out and I'm left with x plus 6. Now I take each one of those and set them equal to 0. And then I solve it. Well, this one's already solved. This one, I'm going to minus 6. So my x-intercepts are at 0 and at negative 6. Okay, and then we're going to take and find our x-intercepts, or our axis of symmetry. So I'm going to go 0 plus a negative 6 divided by 2, and that would be at a negative 3. Then we can take that and plug it in. So if I plug that in, I get y equals negative 3 times negative 3 plus 6. Well, negative 3 plus 6 is 3, so negative 3 times 3 is negative 9. So there's my vertex. From the vertex, I'm going to move right 1 up 1. Then I'm going to move right 2 up 4. Okay, and there would be my graph. And here, if we plug 0 in for the x's to find the y-intercept, we come back with 0. And that is our graph of our quadratic. Okay, take a look at this third one here. We're going to factor it first. Now, remember that when a is a negative, we need to factor that out. So that would give me x squared minus 8x plus 15. So now I come in here to factor it. So I have y equals, and then I have the negative out front. I have my x and my x. This sign tells me the same, so I look back. They're both going to be negative. Factors of 15 that add to 8, and that would be a 5 and a 3. So there is my intercept form of the equation. I now take those, set them equal to 0. And I solve it. So this one's going to be x equals 5. This one's going to be x equals 3. 2, 3, 4, 5. My x-intercepts are going to be 3 and 5. My axis of symmetry is halfway between those, which would be x equals 4. Then we can plug that in. So what I'm going to do is use my factored form. I have negative, and then 4 minus 5, and then 4 minus 3. So that's a 1, that's a negative 1. So negative 1 times 1 is negative 1, but then it's negative, so that's going to make it a positive 1. And if you remember, we're reflecting it because my A is negative. So I'm going to go right 1, down 1, right 2, down 4, left 2, down 4. There's my graph. And then it does ask for the y-intercept. If I plug that into my standard form all the way back here, if I plug 0 into the x's, I get a y-intercept of negative 15, which is off the graph. So I'm not going to mess with graphing that one. All right, last one here. We're going to start in, I do have a GCF again, so I'm going to take the GCF out. Then I come into factor, so I have y equals 2. And then I have x and x. Remember, this sign tells me they're going to be different. I look back, my bigger sign is going to be a positive. So this is going to be plus 3 minus 1. So now I have x plus 3 equals 0. Or I have x minus 1 equals 0. I go to solve it, so x is going to equal negative 3, or x is going to equal 1. Now I come over to graph that, so I have 1 here, 1, 2, negative 3 here. And then if we could add those together. So negative 3 plus 1 is negative 2. Divided by 2 would put me at negative 1. Or if you want, you can visualize it as well, where it's halfway between those two x-intercepts. Now we're going to take and plug in the negative 1. So I have y equals 2 times negative 1 plus 3. Negative 1 minus 1. So negative 1 plus 3 is a 2. Negative 1 minus 1 is a negative 2. So 2 times 2, that gives me a 4. 4 times negative 2, that's going to get me negative 8. So my graph is going to start here. It does have a stretch of 2. So I'm going to go right 1 up 2. And then right 2 up 8, because normally we go up 4. But we're multiplying it by that stretch amount. Also, if you notice, when I plug 0 back into my standard form for my x's, my y-intercept here would be negative 6. And we found that also on the graph. And that is how we do intercept form of a quadratic equation.